Hello everyone, welcome to our high-speed in-vehicle ADAS data logging webinar. I am Anna Korkodilou and I'm the Marketing Officer of Yotta, and today I am joined by Vitali Anselm, the Automotive Business Development Manager in Germany. Vitali, how are you today?
I'm great, thank you for asking. I hope the same with you.
Yep, I'm fine. Well, I would like to inform you that today we are going to show some introductory slides about Yotta, an introduction to ADAS, and then we're going to watch our pre-recorded video from NI, and in the end we're going to have our live Q&A. So, if you have any questions, please submit them in the chat box, and we will be responding in the Q&A. And of course, we have some content that you could download offered by NI about ADAS. Okay, so let's get started. We are your trusted test and measurement partner. We provide test and measurement and lab solutions for engineers and scientists. We started in Bulgaria in 2005, and right now we are covering 17 countries in Central and Eastern Europe with offices and support in 9 countries, including Greece, Bulgaria, Serbia, Croatia, Romania, Hungary, Slovakia, Czech Republic, and Poland. We distribute and support solutions from top test and measurement manufacturers. And if you need a single supplier, we facilitate consolidation for public tenders and corporate procurement. In case you need a turnkey solution, we have developers and domain experts to build your apps. Also, we provide reliable on-site and in-lab calibration services for your measuring instruments. And we offer instructor-led, online, or custom training courses to help you get up to speed quickly. Finally, we provide repair services and extended replacement coverage for your hardware. Our portfolio consists of a wide range of solutions for automating measurements and device control, automatic design, validation, and production testing sequences, building research and teaching labs, and services that include training, calibration, repairs, and application development in LabVIEW through a network of partners with extended domain expertise. We have carefully selected our partners to offer our customers the best solutions, focusing on innovation and quality. NI, our main partner, provides modular instrumentation platforms, including LabVIEW and hardware in many form factors. Cadence, the world leader for software for electronic design. Quanser, providing controls, robotics, and mechatronics lab equipment for teaching and research. Opal RT specializes in hardware-in-the-loop systems. We have several manufacturers like Robotnik, Kinova, and ClearPath for robotics platforms. Etus Research for software-defined radio. Tequipment, Emona, LT Didactic, and many other suppliers providing lab equipment for teaching engineering and science. Ametec for electromagnetic compliance testing. Libellium, Sensi, and many other vendors providing sensors to integrate in your projects. Digilent offering FPGA and microcontroller platforms. And finally, GW Instec offering benchtop test and measurement instruments for your simpler needs. Now, about ADAS. We all understand that today's cars have a lot of sensors like LiDARs, cameras, radars, ultrasonic, AI, and GPS receiver that we need to test. NI offers a proven architecture that enables engineers to leverage off the scalability and flexibility of NI's hardware, software, and services. Therefore, through a single software-connected platform approach, you can integrate all the I/O types you need to test. A nice framework offers solutions in challenges like providing microsecond-level accuracy for sensor and vehicle network interfaces, adapting to evolving vehicle technology for current and future regulatory requirements, managing data capturing gigabyte per second and store hundreds of terabytes per day in vehicle, while still being able to visualize data during road testing, precisely measuring I/O, lossless data handling and data reduction at the beginning of the data lifecycle, and of course, eliminating multiple disparate sensor recording solutions to avoid installation complexity and decrease the risk of failure. Okay, so now let's get started with our video.
Hello and welcome to our webinar, High-Speed In-Vehicle ADAS Data Logging, a key puzzle piece to the end-to-end ADAS and autonomous drive validation workflow. My name is Daniel Riedelbauch. I am the Solutions Marketeer here at NI, focused on ADAS and autonomous driving validation. Before we dive into the details, here is a quick agenda overview on what we will cover today. First, we will have a look at trends and why recording real-world ADAS sensor data is critical. Next, we will dive into the challenges of ADAS and autonomous drive data logging, and we will hear why it's important to think about the value of high-quality data from the start to minimize the total cost of data. For that, we will explore how a single platform for both record, replay, and closed-loop hill can provide leverage and advantages across the validation workflow, including references from Valeo and JLR. Here we will bridge into NI system capabilities covering hardware and software for data logging, followed by a short software demonstration. Last but not least, we will conclude by answering the question why no single company can solve the challenges of the end-to-end ADAS and AD validation workflow on its own, and how leveraging an ADAS and AD ecosystem will help overcome these obstacles. So let's get started. Probably all have seen representations like this one here, showing a vehicle equipped with many different sensors ranging from camera to radar to LiDAR and ultrasonics, plus their sensor field of view. While managing all of these sensors as well as the necessary compute power is a difficult task on its own, it is the huge amount of data that is generated which provides a complex challenge not only within the vehicle, but also within the validation process and workflow. Just to give some perspective, we are talking about gigabytes per second that get produced and need to be handled. This is one reason why many people in the automotive industry call data the new gold or currency. But we will hear more about that later. Another trend that hopefully almost everybody has heard about is the shift towards more and more simulation or using virtual reality for earlier testing. As shown in the test continuum here, shifting validation tests to the left provides tremendous benefits in terms of test coverage, speed of test execution, and test flexibility. But we also know, in particular from examples in the news, that even the best model can never fully replace the real world, and therefore test methods like hardware in the loop or road testing will stay for sure. Even if in the current and more so in the future state, the ratio of tests done on the road and in HIL will be very small compared to testing in the virtual domain. But keep in mind, we are talking about percentages here and not absolute numbers. So again, to summarize, the overall number of tests done in all three areas shown here will further increase, while simulation being the biggest growth driver. Recording ADAS sensor data plays a critical role here, as it provides one way of generating high-fidelity test data by capturing different and especially corner case scenarios while doing road testing. Plus, the recorded data can be replayed and resampled to leverage it as part of simulations to further improve the balance between test coverage, test speed, while increasing also the contribution of real-world test scenarios. Let's take a high-level look at how a vision for ADAS and autonomous driving software validation does look like. As mentioned before, data has become the currency that will be exchanged between the many different parts of this vision. The data sources are typically broken down into simulated and recorded data sets swimming in your data lake. From here, the data gets transferred and used for testing within the virtual domain, represented here by the cloud on top, and the physical domain, shown as a test farm and road testing on the bottom. In between, a sophisticated process of managing test cases, test data, and test assets is required to properly schedule and orchestrate the whole workflow. Like I said, data represents the exchange mechanism, the currency here, and is used within this cyclic process. As this webinar is about logging of ADAS sensor data, which will be fed into the ADAS validation test methods afterwards, let's have a closer look at the work and data flow, the actual data lifecycle. The data lifecycle process starts with the sensors producing the data, which then have to be acquired by an edge compute data logging, storing our recordings locally. Once the test ride is completed, the data needs to be offloaded from the in-vehicle recorder, either through a copy station or even by shipping physical storage units. At the end of the day, the data will have to be ingested into an IT cloud infrastructure, so it can be stored permanently, distributed, and accessed. Obviously, this is not all, as a significant amount of number crunching and preparation will have to be done in the background to make sure that the data is ready to be consumed by our validation test process and test strategy, spanning the whole breadth of the V-design and test cycle. Keep in mind that the middle piece representing the IT cloud infrastructure is a huge beast to tackle with many complex issues. We clearly recommend teaming up with an IT and cloud subject matter expert who will bring the expertise and the technology to the table today and tomorrow to solve these issues with you. As an automotive test and measurement company, we at NI do focus our investments around the areas of ADAS data record, data replay, and HL. Let's dive into the challenges of in-vehicle ADAS data logging now. So what is it that OEMs and suppliers are facing? Well, starting again with the sensors. These obviously need to be tested on a component level, but will quickly be added into specific functions like parking assist or lane departure warning. Here it already is required to have multiple different sensor types involved to achieve the necessary functionality. This highlights that soon after moving from component level test to functional and system level test, validation data and scenarios are required from all sensors to achieve proper test coverage. This requires to record these huge amounts of ADAS sensor data streams, which easily get us to rates of 5 to 6 gigabytes per second. Furthermore, these data streams have to be tightly synchronized and timestamped so that later on in the lab, the data can be reused again for replay and resampled for HAL applications. The recording of raw data instead of just object list information is also very critical, as the many different function owners will have different requirements to be fulfilled, as well as legislation is still in progress. For both of these different and changing requirements, pure object data will not be enough, and no OEM and supplier wants to be the first to get sued for inappropriate testing. So where to does all of this lead? Many times you will find multiple separate single box solutions for each sensor as used in component level tests, leading to issues for data synchronization, timestamping, and defining a system level master clock. Furthermore, the installation, maintenance, and upgradability of this system of systems is a nightmare. Plus, with more and more systems, cables, and connectors, the risk of failure simply explodes. OEMs and suppliers are eager to get to a one-size-fits-all solution, which currently is not ready and not available on the market. Let's summarize it again. The challenges of ADAS and autonomous drive data logging come in many different flavors and therefore make it a complex task to solve. We will find the need for interfacing with many different sensor types and vehicle networks. And even more so, the combination and setups we will have in one vehicle will greatly vary from another vehicle. Synchronizing all data streams is key, as we will need to play them back again as part of our validation workflow, feeding the data into, for example, the Fusion ECU, which needs to get all correlated data streams at the same time, so we can test the decision-making algorithms properly and release features with confidence. As you can see, there is a whole lot more of issues we have to address, all related to data. Whether it is the pure amount of data, quickly getting us into terabytes and petabytes, or how we guarantee the quality of these huge data streams and ultimately make sure we utilize the data while minimizing data waste. How do we easily and quickly offload data, not only from a single vehicle, but from a fleet of vehicles distributed all around the world? How do we make sure that the data we record then gets transferred into our IT and cloud infrastructure so we can actually start to use it as part of our validation process? We can clearly see that there is a tremendous amount of questions to ask to ourselves when talking about the impact of data in the whole ADAS and AD validation workflow. And ADAS data logging is just a starting point to all of this, and is clearly not the main cost driver, but one that can help save costs if done correctly. But what is the actual cost of data? Let's see if we can model that out. As mentioned before, data is the new gold or currency, and once we bring the ADAS logging application back into the overall validation workflow, we can also make the actual exchange rate visible. I wanted to focus on some of the numbers related to data. In our example, we start with a fairly decent data stream of 2.6 gigabytes, which leads up to about 74 terabytes worth of data for a 8 hours test drive. If a vehicle gets utilized about 15 days or 75% a month, and we have 50 vehicles in our test fleet, we will end up at about 50 petabytes of data per month. Now, how do we translate that into money? One simple way of doing so is by using an AWS pricing calculator, which you will find linked at the bottom. So as you can see, 50 petabytes of data equal 640,000 US dollars. And that is a reoccurring fee each and every month. For sure, there are other ways and other vendors which can create a data lake for you, but rest assured, this is where the money will go to. Okay, I hope this explains in a very clear way why data can be seen as a currency and that it comes with quite a heavy exchange rate. Back to ADAS data logging, which is the entry point to our total cost of data dilemma. So what if we can reduce the amount of low quality or wasted data? What if there were ways to shift some of the data reduction further to the left and execute them right at the edge? Plus, what about all the other challenges and requirements regarding synchronization, changing sensor setups, and vehicle bus communication, which we all need to cover? Let's have a look how an industry standard test system platform can help address those. If you're familiar with NI, you probably guessed right. This is about the PXI platform. You can see an image of a PXI-based system in the middle of this slide. In a nutshell, this is an open, modular, and software-connected high-performance computation and instrumentation platform. It provides in-chassis or external computation, very similar to an industrial PC running standard operating systems like Windows or a Linux real-time distribution. It includes latest technology in terms of PCI Express Gen 3 chipsets for high throughput data movement. As this is predominantly an instrumentation platform, it also comes with an extension to the PCI Express bus for in-system timing, triggering, and synchronization, way below the microsecond level. All incoming signals can be timestamped as they arrive at this centralized system, making sure we have precise data correlation within the time domain. We will talk about some dedicated instrumentation modules later. Here, I just want to mention that different I/O boards for interfacing with ADAS sensors and vehicle buses can be mixed and matched and changed at any given point in time. But the true power of this system architecture is enabled through software. As we are running, for example, a standard Windows operating system on the in-chassis industrial PC and provide interfaces and APIs to and from our software toolchain to many third-party software toolchains. This truly becomes an open, modular, and software-connected high-performance computation and instrumentation platform. It connects, measures, and controls a variety of ADAS sensors and systems under test, as well as it connects to simulation environments for scene generation, data replay, up to closed-loop hardware in the loop, including real-time model execution, fault insertion, and rest bus simulation, as well as many more. These capabilities make it the ideal core system for an ADAS test platform ranging from record to replay and closed-loop hill. Here is a block diagram and layered overview on how we bring this software and hardware system architecture to life and how it serves both the record as well as the replay and hill side. On the left side, you can see the ADAS data record setup, including the many different interfaces and I/O needed to log and store the data at the edge within a vehicle. On the bottom, you will find the replay or hill system setup. While we can leverage a lot of the built-in technology regarding timing and synchronization, plus the interfaces and I/O devices, there are elements like fault insertions, load management, model and simulation environments that have to be added. Many of these building blocks can be found within the NI product portfolio, but there are definitely areas like, for example, when talking about simulation and modeling tools, where we rely on the subject matter experts by ensuring we can integrate their IP into our setup and workflow. So these would typically be companies like the MathWorks with MATLAB Simulink, ANSYS, or also like IPG CarMaker, just to name a few. This way, we can benefit from either preserving investments you already made into a certain toolchain, and you will further be able to profit from the innovation and development pace the multiple subject matter experts bring to the table within their area of expertise. Trying to do all of this on your own will not lead to success for you, as other market players will simply outperform us in terms of innovation pace. In the middle of the slide sits the IT and cloud domain, which contains the scheduling and orchestration functions, as we already discussed as part of the high-level vision for ADAS and autonomous drive software validation workflow. In the area, you will find things like test data management and test asset management tools from an I, which can be deployed and used again for both managing our ADAS loggers installed into our fleet of vehicles or for managing agile farms. With this, we can create synergies between the different test methodologies and make sure that leverage of hardware and software translates into streamlined training, increased proficiency, and ultimately speeds up the development and testing cycle. Let's have a dedicated look at how we connect to the actual sensor chain by starting with ADAS logging and then moving on to replay and hill. Here we see a representation of an ADAS sensor chain. Now, there are various test access points throughout this ADAS sensor chain from which we can extract data. We can start right after the sensor where the raw data is produced. This will require handling of extreme high data volumes as none of the data has been pre-processed. Sometimes you will also find a lack of timestamping or an external clock to synchronize your logging system with the sensor and the raw data it provides. Another entry point sits right between the sensor system and the Fusion ECU. Here you capture the data straight from a vehicle network or bus, which then is significantly smaller in terms of pure data volume, but only provides object list information, which might not be enough when it comes down to using the data in our validation workflow for replay and hill. ADAS data logging systems need to be capable of recording both raw and object list data from any given point in the whole ADAS sensor chain, including REST bus artifacts behind the actual Fusion ECU. With the right hardware and software architecture, it is then also possible to use the same underlying foundation not only for record, but also for hill applications. Again, a good hardware and software architecture needs to be capable of injecting data at all of these points, whether it's through target simulation, raw, or object list information. This will allow you, as the user of such a system, to define to which degree you want and need to validate your ADAS sensor chain. Okay, I can almost hear you saying this sounds too good to be true, and it looks nice on a marketing slide, but can you actually prove it? Here we go. First of all, here are two pictures showing how Valeo is using the PXI platform for in-vehicle ADAS data logging. They have been using PXI for multiple years now in ADAS record applications. Just for the sake of completion, you will also find some pictures to the right from our very own ADAS loggers installed into a vehicle. But let's have a closer look at some of the systems that Valeo has developed for both record as well as replay and hill. This is a high-level view of Valeo's system architecture for ADAS data logging. As you can see, it is comprised of a PXI system and a combination of DAC, vehicle network communication, and FPGA-based camera interfaces. Due to their custom needs, Valeo developed their own custom camera front-end adapter modules interfacing with NI FPGA boards. They have invested in training on NI tools, and they have developed their own infrastructure for software, firmware, and I/O interfaces for their logging, replay, and closed-loop hill systems. The underlying foundation for both hardware and software can be leveraged for any logging, replay, and hill application, which saves them a significant amount of time and effort, as they now have a scalable platform which they can simply and easily pull out of their toolbox. And here is the replay and hill side of it. You might notice when comparing this setup with the one on the previous slide that the differences are not that big, which is a testament to the fact that they can really leverage the PXI-based hardware and software architecture across a significant portion of the validation workflow. Just recently, we have concluded our virtual conference, the NI Automotive Exchange. For this event, Marek Kreshalek, assisted and automated driving V&V Senior Technical Specialist at JLR, has been so kind to have an interview with us. And here he was telling the same thing as we just heard from Valeo, that a common hardware and software platform in the ADAS V&V domain creates huge benefits by achieving more robust testing, greater efficiency, and higher product quality. Furthermore, it is phenomenal that through the close collaboration between JLR and NI, we could prove to Marek and the team that our goal really is to provide an open and flexible tool chain which can be adapted to the process of JLR and not the other way. Now that we have heard how and why companies like Valeo and JLR are using the NI hardware and software toolchain, let's spend some more time looking at the technology, starting with the hardware, and begin again from the sensor side. As of today, we are happy to announce that our first FlexRIO automotive camera modules are shipping in December. This camera I/O module actually comes as 6 different hardware variants. First, there are 2 different serializer and deserializer chipsets, one for FPD link 3, and the other one for GMSL 2. Each chipset comes as 3 different I/O variants. A 4 inputs and 4 outputs module for test access point configurations or tab mode, as well as a pure 8 inputs module and a pure 8 outputs module. All versions are shipping in December except for the pure outputs module version, which will be coming later to market in 2021. I will spare you with reading further specs here, but want to emphasize on 2 things. First, the integrated and user programmable FPGA, which allows for inline high-speed data manipulation and processing. More to come in the following slides and how this can be beneficial for ADAS data logging applications. And the second being the data throughput of close to 7 GB per second, which is required for moving raw ADAS camera data to a storage destination through the system. Here's an example how the data flows through the PXI system and the bandwidth at which it can stream. The focus is on how the data will be moved to a storage destination. In total, we have 4 cameras connected, streaming at 8 gigabit per second each, generating a total camera stream of 32 gigabits per second. Now, after the data has been deserialized, it is fed into the integrated FPGA. Note that an optional lossless image compression algorithm is implemented within the FPGA. Due to the ASIC-like performance of the FPGA and its parallel data processing capabilities, this data manipulation can happen in real time as data is acquired. Data compression is a sensitive subject because it affects data fidelity, which is the whole point of data recording in the first place. But you can see that the data reduction of minus 30% can be achieved, and doing so at the edge, this can have a positive contribution to our overall total cost of data. Considering this, the module will inject about 26 gigabits, which equals 3.2 gigabytes per second, onto our PCI Express bus. Depending on the PXI chassis being used, a system can handle up to 24 gigabytes per second. The actual bottleneck sits on the storage side. Using SSD storage devices, we have achieved continuous streaming to disk performance in the range of 5 to 6 gigabytes per second. We spoke about the ADAS camera sensor interfaces quite extensively, as this is the starting point for getting our ADAS sensor data into the data logger. But as mentioned already, there are many more I/O and network interfaces, as well as other devices which can be integrated into a PXI-based ADAS logging system. And for sure, this is only a snapshot, as there is way more from both NI as well as third-party vendors, which is the beauty of an open standard. Starting at the top, you will find the latest PXI Express controller and chassis options recommended for high-speed data logging applications. As these leverage commercial off-the-shelf components like multi-core processors, RAM memory, SSDs, and PCI Express chipsets, you will always benefit from further developments, and you can evolve your system by riding on the wave of Moore's Law. Apart from the automotive camera module, there is a great variety of vehicle network interfaces for automotive Ethernet, CAN, LIN, and FlexRIO, as well as standard Ethernet interfaces to connect to radar and LiDAR sensors, IMUs, or GPS receivers. Special modules for timing and synchronization purposes are an extra benefit of a high-performance instrumentation platform. These modules will allow you to sync to external reference clock sources based on, for example, GPS or IEEE 1588, just to name a few. Last but not least, we need to make sure we can store our high bandwidth and tightly synchronized data streams to a storage device. And I offer several options for in-chassis or external storage devices. An in-chassis storage device is treated equally to an I/O or interface module. An external RAID array is typically connected to the PXI system via a transparent cabled PCI Express bridge. The controller-only version can be equipped with the SSD devices of your choice, while the full-blown RAID array from an I warrants compatibility and upfront testing of the included SSDs. Using the transparent PCI Express bridge, it is also possible to connect with any third-party storage device on the market, which does provide a PCI Express interface. With these many different options, it is within your hands now to mix and match computation, instrumentation, and storage capabilities together to get the best and tailored system implemented, addressing your needs, while always having the possibility to change, adapt, scale, and upgrade as requirements and technologies evolve. We want to make sure that you stay in full control of your ADAS logging test system architecture. We definitely want to include a bit of an outlook as well, to highlight what we are working on to further evolve our ADAS and AD tests, and in particular our ADAS and AD record capabilities. First is an in-chassis storage module with higher storage capacity exceeding the current 4 TB limitation. In addition, we are also working on improved mechanical handling, including bulk storage device on and offloading, to make it easier to physically exchange devices. Moreover, having an appropriate shipping tray for our storage devices will make the physical data delivery smoother and more secure as we are shipping them around the globe. Second, the area of DC-powered PXI Express chassis has been a weak spot for us and will get addressed very soon with a 10 and 18 slot option, providing the same best-in-class high-speed data throughput capabilities as our current AC-powered versions. This concludes our hardware section on ADAS logging, and we will now have a look at how we are unlocking the potential of this open, modular, and flexible ADAS logging hardware architecture by providing a plug-in-based application software experience on top of that. A quick disclaimer up front. Similar to the just mentioned hardware products still being in development, this is also very true to the software which we will show to you today, both from a conceptual as well as demo point of view. So keep in mind, especially for the demo part, that these are engineering samples which will not be fully functional, and that the look and feel as well as the functionality is still subject to change. The main architecture of the ADAS logging software is composed of 3 components, applications basically. First is a configuration editor that lets you choose from the available I/O and UI plugins installed on the system. You will be able to set the necessary parameters for the plugins and define how many need to be instantiated, as well as configure the data linkages between them. The output is a JSON-based configuration file that gets consumed by the second component of the system, which is the core data logging application or engine. This application will read the JSON configuration file, instantiate the correct number of plugins with the defined parameters, as well as start and run the whole background engine, including monitoring the hardware system for errors, as well as communication messages. The data logging application is meant to run headlessly, so it does not require a UI to function. But you may optionally create a UI application which will provide a front passenger experience for an engineer to monitor sensor output streams, as well as send commands to the data logger to take certain actions. Such could be starting and stopping a logging run, or potentially additional features such as annotating or adding metadata to a scene that the engineer wants to document during the test drive. Commands can also be valuable to help address the total cost of data dilemma. Instead of always recording data in a continuous fashion, a front seat engineer can trigger and start a recording through a command once a certain event has occurred during a test drive. A sophisticated trigger mechanism can then make sure to label and only store the data snippet, which will help to reduce the total amount of data that needs to be uploaded to the IT and cloud infrastructure later on. So this is something that can be built into the data logger, basically. For the UI, we are currently considering three options. One being a LabVIEW-based UI application, and another one being a thin client UI, which can be run from a browser. Finally, we will also provide an API to the core data logging engine, which will allow for third-party custom UI applications to be created and connected to the system. Let's have a look at the theory behind this plug-in-based software architecture. As before, we will start from the sensors, our data sources. In this case, a camera, a radar, and a LiDAR sensor. These will need to be connected to our I/O and interface devices. Now, the software path will start by running the appropriate I/O plugins for acquiring data through the camera module and the CAN and Ethernet interface for both the radar and LiDAR sensor. These I/O plugins will be linked to the core data logging engine according to the JSON configuration file. Now, as the next step, the UI plugins need to be run as well if we want to display any of the camera, radar, or LiDAR data. This was just a sample to explain in more detail how the plugin-based software architecture works under the hood. Certainly at this point, we do not have a real logger configured, as we are only displaying the data but not storing it to disk yet. If we build it further, this is how a more realistic setup could look like, including more camera sensors, additional bus communication, as well as storing the data stream to disk. This should give you some perspective on how both the software and hardware operate together to define, implement, and run a sensor configuration specific ADAS logging application. But let's take a step further and explore how it would look like to make changes both to the hardware and software setup. So in our case, let's swap out the automotive Ethernet, FlexRIO, and LIN buses and replace them with more cameras. As you can see, we will only have to change things on the hardware as well as the software side along the path of the data from the sensor to the UI and storage. But apart from that, the remaining application stays untouched, which makes it straightforward and reduces the amount of time spent on updating and maintaining the system. Having said that, let's move into the real demonstration now and see things in action. For this demonstration, I have logged into our PXI ADAS data logging system. So as you can see, I'm working right off the PXI controller installed into the chassis. I'm running a Windows operating system. Just to let you know how the configuration looks like, so we have two cameras connected via GigE to the PXI system, as well as one radar sensor connected via CAN, and another LiDAR sensor connected via standard Ethernet. So let's go ahead and start off with using our configuration editor. What you can see here is the editor on display, highlighting 4 tabs to the left-hand side that we can use to define our configuration. Let's go ahead and go into I/O plugins. So currently, no plugins have been defined, so I'll start adding one by hitting the plus button over here and starting off by selecting a camera capture plugin. Calling this, in this case, my camera acquisition plugin, basically, and changing the name down here where it says camera name to cam0, because this is the reference to the camera, how it is called within our system, so that it knows like where to grab the data from. So with that, we have a camera capture data acquisition plugin defined, but we need to also define a destination for the data where to go. So let's hit plus again and add another plugin. In this case, we want to make sure that we are logging our data. So let's give this also the name of cam0 log in this case. And then we simply need to provide a path where this should go onto our system here, into our logs folder. And we simply also call that cam0 log.tdms. So here we go, save that. So now we have defined that. And last but not least, what I also would like to do, I want to make sure that we can also display the data on our UI. So again, I hit plus, select from my installed plugins, basically the so-called camera image processor plugin. And what this does, it not automatically displays the data on screen into our UI, but this is first and foremost to resample the data stream, basically adjusting the resolution, as you can see here, and also do some UI decimation factors in terms of only grabbing every 10th frame from the camera data to display it on the UI. So let's also give this a name. Let's call this cam0 process. So we have that, and now we have 3 plugins defined. Still, we need to make sure that we link them together, because right now that the data does not know where it has to go. So let's go to the IO links tab here. Again, hit the plus button, and now I simply take from my defined plugins the camera acquisition, connect that to my camera0 log. Then I take again my camera acquisition. Add another one. Take my camera acquisition and make sure that this goes to my cam0 processor so that it gets resampled, and I can use that later on to display on the UI. So this is a basic way how you would configure these plugins. Let's go ahead and load a predefined configuration so that you can see also how this looks like for multiple devices being configured and plugins to be configured. So going back to our IO plugins, as you can see here, there have been many plugins defined for cameras, also again camera processors for displaying them. We have a system health plugin defined here. As you can see that we also have our LiDAR configured, which is grabbing the data through our Ethernet IP or UDP communication basically, and so on and so forth. We can see the links that have been defined here. And what I still want to show here, because we haven't seen that yet, is basically our UI plugins. So this is what is defined here. So again, if you click on one of these, you can see the configuration parameters. And here is basically what is called the data topic. And this right now shows off as camera 0. And this is also what's defined, for example, in our camera processor 0 here as the UI topic. And this is how these get connected basically together. Last but not least, if I have all of my UI plugins defined, I still want to put them onto my UI, into the grid that we have here. And this is then again done here through this UI layout, similar fashion as we have seen on the IO links tab. We grab off the UI plugin and we define a spot on the grid where it needs to go, and we can also add a name to that. This is the second part of our ADAS logging software demonstration. So what I've done now is I started the ADAS logging core engine. So this is running underneath, and it's connected basically to my UI interface that we have configured through the configuration file earlier. So let's get to a quick rundown what we can see on display here. On the left-hand side, you see our system health plugin. So that provides us with valuable data around like how our PXI system is actually doing. To make sure that we can monitor it all the time. On the right-hand side, we have our UI plugins for our sensor data. So you can see our two cameras on display. We can see our radar sensor via CAN, and we can also see our LiDAR on display. By clicking onto the top of the cameras, we can also zoom in into those. So really to make sure that the
Hello, Vitali.
Hello again.
So this was all very interesting. Do you have any comments from you?
Yes, sure. I mean, my colleague, he already summarized a little bit at the end of the presentation, the main takeaways. Maybe just to rephrase and put the takeaways in my words, we heard also from Anna at the beginning that we are facing with the new challenges on the market because especially if it comes to the transition from advanced driving assistance, from ADAS to autonomous driving, from level 2, so to say, to level 5 or level 4. We will always see that the number of different ADAS sensors will grow. It will be doubled, it will be tripled, depending on the use case and on the customer that is building these autonomous driving shuttles and vehicles. And obviously, this has also something to do with the growing complexity. And in order to solve the challenges of this complexity and to cope in general with this new amount of tasks, I would say that you as a customer, you would like to minimize the system complexity in general, which means in the past, you had maybe for each of the sensor types dedicated and separate logging solution. And this means also in the background that you will have also to synchronize the data between all these separate loggers. And therefore, you would like most likely to consolidate all of these loggers, separate loggers, into one single unified system in order to have everything at one place, synchronized and at your hand at any time. Then you most likely would like to increase the data quality, which also involves the ability to log the data with a very high throughput, to have all the data synchronized with each other, to have also a big variety of different IOs in your system. Then I would say you would like to have more than just a logger, but rather a single unified tool chain. And we heard also in the presentation previously that customers like Valeo, for example, they are not using our platform just for one specific use case, for one application, which is recording the data in the vehicle, but also reusing the same platform to replay the data in the lab after that, in order to have 100% reproducible test cases in the lab without the need to go again on the test track and to record this data again. And then last but not least, I assume you would like to have also a future-proof system, which means you would like to have a flexible platform that is capable and allows you to adapt and customize the platform to your needs. Let's say today you need only this small set of sensors to be logged. In the next project, next year, you might have increased complexity, increased number of different sensors and input signals. In this case, you would just scale and the flexible adapt the system to your needs. And all of this mentioned unique capabilities and features, this is something that NI ADAS logger, or we call it a data record AD, is supporting you to do so and is allowing you to solve these challenges that you might be faced with now. So this is just a short rephrasing of different takeaways from this presentation from my side.
Thank you very much. And since we are now at our Q&A section, I know that there are some commonly asked questions that I would like to ask you some. Like, we see that vehicle architectures are changing, and how does this impact logger strategy?
It's a good question, and it goes also a little bit in the direction what I said before, because the new architecture, they have a trend to consolidate the different ECUs and domain or component ECUs into one single central one, and which becomes a more complex one because it has to deal with more different inputs and output signals and to process it. So it needs also high computation power on it. And in general, it goes in the direction of having more signals, more complexity, which you have to test, and therefore also the logging architecture has to grow with the new challenges, with the new requirements, which makes it actually mandatory to have a flexible and scalable platform to be able to in an agile form, adapt to and customize to your current and future needs, which I mentioned before. This is something that NI tries always to be open, to be scalable, and to be future-proof. Yeah.
Great. Well, I see one question here regarding vehicle networks. Can we model vehicle-to-vehicle communication? For example, a vehicle informing another for its geographical position.
The question is about vehicle-to-vehicle communication.
Yep.
I see the question. In general, yes, sure. It is maybe going more into another direction, not to the logging application-specific question. But in general, NI is supporting customers also in other areas outside of logging application, which is going into software in the loop, hardware in the loop simulation. And if you are going to test vehicle-to-vehicle communication, like V2X, for example, either it's cellular V2X or DSRC, we do have also solution for developing application for the vehicle-to-vehicle communication and also for testing that. And of course, I'm happy to have a call and another conversation with you to go more into details around V2X.
What would you say is a typical software setup for an ADAS data logger?
It depends. It depends on customer needs, of course. One customer maybe prefers to have a sophisticated graphical user interface, which can be used during the drive, during the driver is going with a vehicle on the test track, and would like maybe to interact with the software and even push some buttons to record also metadata. For example, okay, today it's night. It is raining. We are going now in the roundabout. I have seen now some animal on the street. So this kind of interaction between the driver and the software, in some cases, is needed. In this case, of course, the software would comprise also of a specific graphical user interface. In some cases, the customer says, I don't want to interact with the software at all. It should just be robust and log the data as fast as possible and as synchronous as possible, and should be completely headless without any graphical user interface, and have maybe just an API. And I believe my colleague was mentioning that we are supporting gRPC interface to output all the data to the third-party component, or to interact and receive and react to some comments via gRPC. So there are different use cases and therefore also different software types that we can offer here.
Okay, and what else can we do beyond the logger?
It's a good question. Actually, the recording, the presentation that we have seen is already 10 months old, I would say. In the meantime, yes, we have evolved, of course, and some of the presented solutions that my colleague was highlighting, that it is still in development. Meanwhile, it is already released, including some hardware components like DC chassis released. The graphical user interface is also a different one, not the same that was shown. And I'm happy also to jump on a call with you to present more details around the current version of our ADAS logger. We have entered the strategic partnership with Seagate, which is offering storage as a service. So you are not buying the hardware and the disks, but you are paying basically for what you are using. So you are paying for a terabyte that you are using. And beyond that, there are some services like even shipping the disk between the countries. We have, in the meantime, also acquired another company, which allows us not only record the data, but use this recorded data in order to automatically create a digital representation of the test track. We call it real to virtual, or creation and generation of digital twins. And the company is called Monodrive. And now, so we have also the possibility to move the recorded data into the simulation world, which is done also automatically. And of course, beyond ADAS record and in-vehicle data logging, you can do a lot of that. One example was mentioned in the presentation that the customers are using the same platform to replay the recorded data in the lab, or to, once you have moved the data and created the digital twin, then you can do any kind of permutation in the software in the loop or hardware in the loop in order to test the different scenarios in your ZIL or HIL environment.
Thank you. Another one.
Sure.
How do you deal with the harsh environments, like your logger might find itself, let's say, off-road or mining?
It's a good question, not very frequently asked, because usually we are dealing with tier 1 automotive or OEM customers who are interested in vehicle ADAS logging. However, we do have also customers from mining or off-road domain. And in this case, indeed, it is important to deal also with harsh environment, with dusty environment, with vibration and shocks, of course. And in this case, we, as my colleague mentioned, we have a big ecosystems of different companies. We call them partners. So we have a very huge partner network. And depending on the requirements, our partners can build a special encapsulated box for our PXI chassis in order to deal with air conditioning, with the additional suspension for vibration handling. So this is something that we can address, and we have been addressing also for several customers in this domain.
Nice. Which synchronization options do you offer with your logging system?
Again, synchronization is a very important topic if it comes to logging the data, especially if you're not logging from one signal source, but you have, let's say, different ADAS sensors and also ECUs connected to your logger. Then it's obvious you would like to record everything synchronized to each other. And in this case, again, depending on the preference of the customer, it can be based on the PTP or IEEE 1588 standards, where you are sharing the synchronization signal among the Ethernet, in this case, in this Ethernet hardware, or you would like maybe to have an external hardware trigger for all of the systems, either using GPS signal, or you could also use our backplane. So our backplane, where all the I/O boards are connected to, is very tight synchronized with 100 megahertz synchronization tagged, and therefore you can achieve a very, very tight synchronization below 1 microsecond. So there are several concepts, and depending on the preference of the customer, or also on the already existing architecture of the customer, where maybe we as an eye are coming into play and bringing some additional components into the existing architecture, and therefore, of course, we have also to comply and honor the already existing synchronization techniques at the customer.
And how are you dealing with electronic supply shortage?
It's a good question and very actual question, I would say, because we are faced with the shortages on the markets, and of course not only NI, also other companies are affected by the supply chain issue. And as I mentioned, for example, Seagate, our partner for storage, providing storage devices and storage solutions, they don't have any, they are completely not affected by the supply chain, and they have enough in stock, and they can deliver the storage devices and solutions as soon as possible if the customer wants it. So we have different applications and different use cases where we are not that much impacted. However, of course, there are some here and there, some shortages because our portfolio is huge. If you take a look what kind of hardware devices we can provide from our catalog, of course, there will be some percentages of that where our usual delivery time is now a longer one. But it's obvious it's a problem. It's a global problem, not only for NI.
Yep, that's true. So in 6 gigabytes per second, the limit of the system in its maxed out config is what?
As far as I remember, my colleague during the presentation, he was showing how the data flow is looking like from the sensor or from the hardware through the I/O boards and our backplane. And he mentioned also that the main bottleneck is actually the storage itself, while our backplane is capable of driving up to 24 gigabytes per second. The limit is actually as soon as you're starting to download the data to the SSD, to the storage, then it's usually limited to 5 up to 6 gigabyte per second, which is around 48 gigabit per second. And so this is just a physical limit. There's nothing on the market that would make it quicker. What you can do, of course, if you want to increase and go from 5 or 6 gigabyte per second upwards, then you can just place in parallel several RAID solutions, several of the storage devices. In this case, you can parallelize the upload of the data, and therefore you can. We have, for example, done a POC with 3 devices in parallel, and therefore we could shift 15 gigabyte per second easily in this case.
Okay, and let's say that we have some existing infrastructure in our team, and we would like to reuse existing content, meaning hardware and software. Is there a way to integrate the logging solution to these tools or vice versa?
Yes, definitely. As I mentioned before, so we are also historically, and I sometimes was perceived as a provider of Lego blocks. So you could get some components out of our portfolio and based on that build some solution. And again, we do have this ADAS logger solution that we are promoting as an entire solution that you can use, and it's basically turnkey solution. But again, it is based on different separate components from our portfolio, and therefore it's still possible to just incorporate some portion of our ADAS data record AD solution into the existing architecture, into the existing solutions. And we do have examples where, for example, the customer had already some in-house built software solution for the logging, and they just wanted to replace their in-house hardware solution by the off-the-shelf hardware components. And in this case, it was easy, and they just were reusing the software they had together with our hardware components. So again, we are open, our platform is open, and we have different interfaces and standards that we are supporting at NI, and therefore it's always easy to integrate our solution into already existing situation.
Okay, well, so I don't see any other questions. Is there anything else you want to add before closing?
Yes, as I mentioned before, the presentation is from last year. In the meantime, many things happened, including acquisition, including release of new hardware, and other things. Therefore, if you if you find the presentation and this topic interesting and you would like to deep dive with us in more details, I'm happy to have a call, to jump on the call with you and discuss your requirements, your projects, and see how our solution will fit and will solve your requirements and challenges.
Good. Of course, feel free to contact us. Thank you for joining, Vitali. Thank you very much for assisting and being here. And we're looking forward in the future to deliver more webinars about ADAS or whatever interest you have. Thank you very much. Goodbye.
Thank you. Goodbye.